All right, so next up we're going to talk about scatter plots. And so your learning target is I can create and interpret scatter plots. So first thing we're going to do is we're going to do a couple of definitions and take a look at a couple of things. So the first thing we're going to define is what a scatter plot is. And a scatter plot is a graph that shows the relationship. Okay, so relationship is that first blank there. It shows the relationship between two sets of data. Okay, now there's two correlations. Okay, and correlations is what describes the relationship that the two sets of data have. So scatter plot shows relationships between data. Correlation describes those relations. Okay, so correlation describes is that second blank. And there's three types of correlations. There's first a positive correlation. That is when both sets of data values increase. So we can see how as x increases, y is also increasing, and so this is a positive correlation. The next type of correlation is a negative correlation. Okay, that's when one set of data values increase as the other set decrease. Okay, so increase and decrease, and we can see as x is increasing, y is decreasing. It's on its way down, right? So that's a negative correlation. And then finally, I'm going to go ahead and move this down just a little bit. There's no correlation. No correlation. No correlation. It says there doesn't seem to be any relationship between the given data sets. And we see on this graph here, there's a bunch of dots all over the place. There really isn't any way to tell what a relationship is. It looks like it's just kind of completely random. Okay, so there doesn't seem to be any relationship between the given data sets. So in example 1, all we're going to do is we're going to practice actually graphing a scatter plot. Okay, we're going to graph a scatter plot. And it says the table shows the number of cookies in a jar from the time since they were baked. Graph a scatter plot using the given data. Okay, so there's the time since it was baked, the cookies were baked, and this D stands for days. So 1 day after it was baked, how many cookies were in the cookie jar? 2 days, 3 days, 4 days. Okay, so if we look at this this graph over here, first we should identify that this x-axis is the days of since baking. The days since baking cookies. Yep. Okay, and then the y-axis is the number of cookies, or just cookies. Okay, and so if we were to graph this, we see that at 1 day there was 24 cookies, so we'll go 1 day up to 24. 2 days there was 16 cookies. 3 days there was 10 cookies, and 4 days there was 7 cookies, right? So all we're doing is we're pretty much just trying to graph this. A lot of the times you're going to have a lot of things to graph. This one doesn't have necessarily a lot of things to graph. But we could also, just with the given data, kind of give a correlation. We could describe this scatter plot. The question doesn't ask us to, but we see that as x increases, y is decreasing. And so this is called a negative correlation. All right, in example 2, we're just trying to get a little bit better on how to describe a scatter plot. And so the question is, what type of correlation is illustrated by this graph? And we see that as x is increasing over here, y is also increasing. They're both going up. It's on an uphill climb. And the type of correlation that describes that is a positive correlation. So this would be an example of a positive correlation. All right, example 3 asks us to kind of think about a situation and decide what type of correlation would be expected to be seen between the pair of data sets, and then we have to explain it. Okay, so we're given 3 situations here, and we have to decide what type of correlation might be given. So this first question is the average temperature in a city and the number of speeding tickets given in the city. And if we think about this for a second, do you think there's really any correlation between if the temperature is nice, then there's more speeding tickets? Not really. I mean, there could be some sort of event where that happens, but really, I would guess that there would be no correlation. Really, temperature doesn't describe how many speeding tickets are given out. So no correlation. Temp doesn't have an impact on speeding tickets. We don't know that it does, or it just doesn't seem like it maybe would. The second one, it says the number of people in an audience and ticket sales. Well, the more people in an audience, the more ticket sales there would be. And so we can see that because of this, this would be considered a positive correlation. And to explain that, the more people in an audience, the more tickets were sold. Okay, and finally, let's do this last example here, and I'm going to move this down just a little bit. It says the time since the start of the race and the runner's distance to the finish line. Okay, so we would assume that as a runner is running longer, they're getting closer to that finish line, so that distance is going down, right? So as the time goes up, the distance from the finish line is going down, and so what that would look like probably is a negative correlation. Negative correlation. And what that would be then is the longer in the race, the distance to the finish line would get closer. And that is kind of how we would describe scatter plots and the correlation of those scatter plots.